Hello everyone, welcome back to the channel. I hope you guys are doing amazing. So let's look at today's daily challenge on Leetcode and try to solve it. So the question is 0 array transformation 1. You are given an integer array nums and a queries where each query is li and ri. So for each query what you can do is that select a subset of indices, that is you can select any subsequence also from li to ri from the array nums and decrement the values selected by one in one operation. So in many operations, can you reduce all the array or all the elements of the array to 0? So that is the question. So you see here what they do is from 0 to 2 they decrement only this and this by 1. In one operation they convert all to 0. But if you see there are two queries here, 1 to 3. So 1 to 3 they can decrement at max these three elements they can decrement at max, and for 0 to 2 they can decrement these three elements. So uh, the most optimal array they can reach is 3100. Here not all are 0 and hence we need to return false. So constants are like 1e5. You have to think of solving in linear time only or n log n time. So whatever be the case, one thing you easily observe that whatever be the number, you need to perform an operation at least that number of times. So here is 4. You need to perform an operation at least 4 number of times in order to make it 0, and there are only two intervals here. So of course this is not possible. So but that even if there are more than 4 intervals, then also you will only be able to reduce this to 0 only if the intervals have a 0 in them. So intervals must have the indices. The intervals must have the indices in them, and the value at these indices, that many number of intervals should be there. So let's try to understand how to solve this. So one thing you can easily understand is that, let's say in the array you have an array and somewhere in the middle you have 6 and you have these kind of things. Okay, you have this complete array, somewhere in the middle you have 6. So in the query you are given some intervals in the form of this. Let's say this is an interval, this is another interval given by the query, this is another interval. So you must see that this needs to be decremented 6 times, because in one operations you can only do -1. So the intervals, there must be 6 intervals covering this. So let's say another interval is, let's say this, and let's say the another interval is, let's say this, and another interval is, let's say this. So you see the intervals covering 6 is like this covers 1, 2, 3, 4. Only 4 are there, these two are not there. So if there are more intervals, then only we can say that this element has been covered and reduced to 0. Okay, so for every element you can check that. For every element you can iterate through the array and check whether uh, that can be reduced to 0. So that is only possible if you know that in that position how many intervals covers that position. You need to know that. Okay, so this is a classic line sweep algorithm method. So let's try to discuss what it means. So line sweep is a very important concept. You will require it in many of the Leetcode problems. So what it does is that it helps you find the number of intervals occurring at a particular point, in O of one time. In O of one time, given you need to do a pre-computation, of O of n. If you do a pre-computation of O of n in O of one time, for every query you can answer how many. So how does this work? So let's say what you do, you are given some intervals, right? You are given this array, let's say. Let's forget what are the elements in the array, and let's also, in order to make it more visual, I am just using the intervals. I am not specifying the things. I am just telling that, let's say these are the intervals. Okay. Now what you can do is you can make an array. You can call it a DP or whatever. You, whenever you see that an interval is starting, you first of all you take a zero array, make it all zero. You take an array and make it all zero. Okay. And whenever you get something like the starting of an interval, you increment the array by +1. So let's say I am having a zero array here. I am incrementing by +1 as this interval is starting. Then since this interval is ending here, in this array this needs to be negated, but this interval is starting again here. So what I will do is that I will again increment by +1. Okay. Okay. And what I will say that this interval is starting here, and then again I will decrement this value -1 because this interval has ended. So this is inclusive, right? The position where it is ending, it is including. So after that position, I will do a -1. Then again one interval is starting here. One interval is starting here. So yeah, let's try to adjust the position so that it looks more good. So what I can do is, yeah, this is one. Okay. And again this here again one, because this interval is starting here. Now this interval has ended here, so there will be a -1 here. This interval has uh, ended here, so there will be a -1 again here for this interval, and there will be a again -1 of n+1 length array. Okay. So that's how this thing we need to pre-compute first. So what does it help us? Now you compute a prefix sum of this. If you see, if you compute a prefix sum of this, so it's in where it doesn't have anything, it means it has zeros. Okay. So even if let's say another interval is starting, so you could have done +1 and then again +1 for that interval, it will become 2 here. So there not only one and -1, there can be any number. So you do a prefix calculation. So you this prefix you just calculate. Okay. So what you can see in this prefix tells us how many number of intervals is present at a particular point. In this particular point, there are two intervals. If you see, yeah, you do understand the concept of line sweep now, right? In this particular point, there is only one interval. Now you ask me, in this particular point, there are three. Uh, there are two intervals actually. So this is not 3, this is 1. So prefix sum is calculated by taking the sum of previous number and this number. So previous number and this number addition will give 1, this number and this number addition will give 2, this number addition will give 3 and not 4. So this will give 3, this number addition will give 2, this will give 1. Okay. Okay. So you just correct it, 1 1 1 and again 0. So you see this, if you ask about this position, how many intervals fall in this position, you can just see in the prefix array that there are only 2. This position you can see visually that this is not an interval. So this position you can see visually that there are 3 intervals, and also the prefix array gives that there are 3 intervals. So you are marking the beginning and ending of every interval and checking that in one position how many intervals it does cover. So yeah, the coding part is really easy. So if you get the number of intervals in O of one time, you can easily see all the query and check that. Let's say you have a 6 here, as I told you, whether there are 6 intervals or not. If there are less than 6 intervals, you cannot reduce it to 0, and if there are 6 or more than 6, you can definitely reduce it to 0, and hence it is possible. So for all the positions, this need to be satisfied, and if for one position it is not satisfied, any one position, then we will return the boolean as false. So let's try to code it out quickly. You have the nums dot size. Okay. I am keeping a vector int as line sweep. I'm calling this line sweep. So what it does is that it goes through all the queries and it will increment or decrement. So if it has a L, queries have Li and Ri, so I am just extracting those out. Li and queries have Ri also. And what you will do is that line sweep of L you will do plus plus. Okay, initially everything is 0 in this array, so you will do a plus plus, and also line sweep of R plus 1 you will do a plus minus minus, because the interval is now ending here. Okay, you can definitely keep a prefix array now. You can keep a prefix array of the same length, and definitely pref of 0 is nothing but line sweep of 0. So the classic method of calculating the prefix array is nothing but this. So it starts from 1, first I have already taken care of, uh, and it iterates through this to give pref of I equal to pref of I minus 1 plus uh, line sweep I. So you calculate all this, you have the prefix array now ready. So in O of 1 time you can just tell that which element is having how many intervals in this. So all you need to do is iterate through the nums array. You also keep a bool answer. You set that to be true initially, because if one condition is false we will just break the loop. So we go through the nums array and see if nums of I is greater than pref of I. You do understand it, right? Pref of I needs to be greater than or equal to nums of I. So if you anywhere you see that the nums of I, let's say 6 here, is greater than the number of intervals, which is 1 here or 2 or whatever, if that, then it cannot be reduced. So set answer equal to false and then break it. If anywhere this is true, then just set it false and break it and just return answer. So yeah, that was all. Let's try to run it. Yes, we do have this accepted it thing. Let's try to submit it. So yeah, we do have the accepted case. Runtime is okayish, and I think this was an easy problem if you know the line sweep algorithm, and if you don't know, once you know it, things will look really easy. So yeah, this was definitely a medium problem for today, and I hope your day is going to be really easy. Thank you so much.